we can use the same reasoning when it comes to consecutive odd and consecutive even integers. If we start with an odd number and add 2, we will have another odd number. And if we start with an even number and add 2, we'll have another even number. So, to find consecutive odd or consecutive even integers, we use n plus 2, n plus 4, and n plus 6. Now, I want to show you why we're adding 2. So here I have my odd numbers, 1, 3, 5, 7, 9, 11. Let's see what happens. How do I get from 1 to 3? You add 2. How do you get from 3 to 5? You add 2. How do you get from 5 to 7? You add 2. How do you get from 7 to 9? Add 2. How do you get from 9 to 11? You add 2. What if I wanted the next odd number? Well, I would add 2. 11 plus 2 is 13. And you could keep going forever. Let's look for even integers. So here my even integers are 2, 4, 6, 8, 10, 12, and so on. Well, let's see how I get there. How do you go from 2 to 4? Add 2. From 4 to 6, add 2. From 6 to 8, add 2. 8 to 10 you want to add 2. And 10 to 12 you're also going to add 2. If I wanted the next even number, well, I would add 2. 12 plus 2 is 14. And I could keep going. So if you look, it doesn't matter if you have an odd number or if you have even numbers, you're always adding 2. And that is why here, instead of adding 1 every time, we're adding 2. So that's why that works. So on this next example, it says find 3 consecutive odd integers whose sum is 111. Show all work algebraically. So I'm going to have my first number plus my second number plus my third number, and that's going to equal 111, right? Because that's what they tell me right here. Again, I'm adding because they told me that I'm finding the sum. I don't know what the first number is, so I'm going to call that n. Plus, I know my second number is the next odd integer, and so that will be represented by n plus 2. Plus, my third number is going to be the next odd integer after that, so that's represented by n plus 4. Well, now I have an equation that we can solve. I'm going to begin by combining like terms. N plus n plus n is 3n. And 2 plus 4 is 6. I want to get 3n alone. To undo addition, I am going to do subtraction. And so I'll have 3n is equal to 105. I want to get n. I want to get n by itself. N is being multiplied by 3. To undo multiplication, I'll do division. And I will find that n is 35. So that means that my first number is 35. My second number will be 35 plus 1, or not plus 1, 35 plus 2, which is 37. And my third number will be 35 plus 4, which is 39. Notice how I have all odd integers. If you get a decimal or a fraction when you're doing this, you did something incorrectly because an integer is not a decimal or a fraction. Also, if I got any even numbers here, I would have also have known I made a mistake because we are looking for odd numbers. So my answer is 35, 37, and 39. Those are my 3 consecutive odd integers that add to 111. Let's try the next one. It says find 2 consecutive even integers whose sum is 26. Show all work algebraically. So my first number plus my second number is 26. Again, I know that I'm adding because of the word sum here. My first number, I don't know what that's going to be, so I'm going to let that be n. My second number, well, I know my second number is the next consecutive even number. So that's going to be represented by n plus 2. Well, now I have an equation that I can solve. I'm going to begin by combining like terms. N plus n is 2n. I want to get the term with the variable by itself. To undo addition, I'm going to do subtraction. And so I'll have 2m is equal to 24. I want to get n by itself. I keep doing that. There we go. I want to get n by itself. To undo multiplication, I'll do division, and so I'll have n is equal to 12. We got an even integer, so I know that we're on the right track. So my first number is 12, and my second number is 12 plus 2, which is 14. So 2 consecutive even integers are 12 and 14.